This lesson is solving trig equations. In this lesson we will be using some of the identities that we have learned before, as well as some of the values of special angles that we have learned before, as well as using our calculator to help us evaluate values for our variable in order to solve trig equations. We're going to start this lesson with some very simple trig equations just to get an idea of what type of solutions we're looking for and how we find those if the equation is simple. Then we'll look at more difficult and complicated equations. Notice in this first equation we are to determine all solutions of the given equation, and we are to express our answers using radian measure. So there's two things that I want you to notice here. First of all, it says all solutions, every one of them. The other thing that it instructs us to do is to use radian measure. So we are not to give our solution in degrees. Now if you look at our equation here, it's a very simple equation. The sine of theta is equal to square root 2 divided by 2. Now whenever you solve an equation, you are looking for the value of the variable that would make that equation true. Well, in this instance, our variable is this theta here. And since we are to express our solution using radian measure, we're to treat theta as either an angle measured in radians or as a real number. So we're to solve for theta. Well, to solve this one, we're going to rely on what we know about the sine values of our special angles. What angle do you know whose sine is square root 2 over 2? You should know that one. Of course, if you're thinking in degrees, you're thinking 45 degrees. But let's remember, we want this answer in radian measure. So instead of saying 45 degrees, we're going to say pi over 4. Okay? Now, let's talk about our solution though. Remember, we're to find all solutions. The sine of theta is a positive square root 2 over 2. Let's review our quadrants. If you learned the little saying, a smart trig class, or all students take calculus or whatever, remember all trig functions are positive in the first quadrant. But in the second quadrant, that S stands for sine function, doesn't it? The sine function is also positive over here in the second quadrant. So our angle, theta, could also be a second quadrant angle. It could be a first quadrant angle like this pi over 4, but it could also be a second quadrant angle. Recall, if we go to the second quadrant with our angle, we use this pi over 4 as a reference angle, and so the angle that we're talking about for the second quadrant would be 3 pi over 4. So another possible answer here for our angle in radians is 3 pi over 4. Now, again, let's talk about this idea of all solutions. What would happen if I did a complete revolution and came back to the first quadrant with a pi over 4 reference there? In other words, I did 2 pi plus another pi over 4. I would still have that very same sine value of square root 2 over 2, wouldn't I? And if I did 2 rotations and back up to that first quadrant, or 3 rotations, or however many, or you can also think about when you graphed your sine function, one period of the sine function looked something like that, but what do we know is true? That period repeats itself going in both directions, and so those places where our sine value is square root 2 over 2 will be periodic, and they will occur every 2 pi, won't they? So what we're going to do to express our solutions here is we're going to take our first solution of pi over 4 and we're going to put a plus 2 pi k on that. Now when we do that, k represents an integer. Integers are the numbers 0, 1, 2, 3, etc., or -1, -2, -3, etc. Those are integers. So notice if k is the integer 0, then we're getting the answer pi over 4. If k is the integer 1, then we're adding 1 revolution, or 1 period, to our pi over 4, and so again we would end up with this first quadrant solution. If k is 2, then we're adding 2 periods or 2 revolutions. If k is -1, we're simply doing a revolution in the negative direction. So we'll do that with our second answer as well to get all possible solutions there when we do rotations or periods to find those other values where we have the sine value being square root 2 over 2. Now I like to refer to these two solutions as my primary solutions, just doing one rotation. And then by inserting this 2 pi k, adding on there, then I take into account rotations, complete revolutions back to where I was before. Now if you are giving your solution in degrees, instead of adding 2 pi k, you could add 360 degrees times k. 360 degrees being one revolution, just like 2 pi being one revolution in terms of radians. Now in this example, our sine value was a value for which we recognized what the angle had to be. It was a special value. That is not always the case. So in these next several examples, we're going to see a situation where we have to use our calculator to help us find that value of our variable. Use a calculator to find solutions in the interval 0 to 2 pi. Round off to 2 decimal places. Now let's look at this equation. It says the cosine of x is -0.567. Now our variable that we're trying to solve for is x. So again, x is an angle or a number, if you will. What type of solutions do we want? Look at what it asks here. We only want solutions in this interval. Well, because we're saying 0 to 2 pi, this is indicating radians to us. If we had wanted degrees here, it would say 0 degrees to 360 degrees. Now, since we do not recognize this 0.567 value like we did the square root 2 over 2 value, we will go to our calculator. Now be sure as you go to your calculator that you have it set for radians. And we will just use our inverse cosine key on our calculator to get an approximate value. Now I'm going to use sort of a wavy equal sign here to indicate that this is not going to be exact because we're going to be rounding off. Now keep in mind that every calculator is a little bit different. You may do your inverse cosine key first and then do the -0.567. Others of you may put in that -0.567 first and then do inverse cosine. But if you will do that with your calculator, your display should be reading 2.173655573. We're going to round that off to 2.17. Now my calculator is only going to give me one solution. Remember, it is programmed to know those restrictions for inverse sine, inverse cosine, and inverse tangent. Since the number I entered was negative, I know that my calculator is giving me the cosine value, which would be in the second quadrant. The cosine is negative in the second quadrant. We also have to remember, again going back to our calculation here, that the cosine will also be negative in the third quadrant. Well, now let's talk about what this calculator solution is telling me. This is taking me over here to quadrant 2 with a 2.17 value. Now remember, we're working in radians. Over here is pi, which is approximately 3.14. So what I'm going to do is I'm going to get my reference angle here by subtracting this 2.17 from 3.14. So my reference is 0.97 right here. Now if I'm going to go to the third quadrant for my other place where the cosine is negative, then I need to use this 0.97 as a reference also there. And so what I will be doing is 3.14 plus 0.97. Have then 3.14 plus 0.97 is 4.11. Now we have found two solutions here. We have found a solution in the second quadrant and a solution in the third quadrant. Do we need to add on these revolutions like we did in the previous example? And the answer is no. because notice we're only to find solutions between 0 and 2 pi. If you go from 0 to 2 pi, that's only one revolution. And so we only want these two solutions for our equation. Use a calculator to find solutions in the interval 0 to 2 pi. Round off to 2 decimal places. Notice here we have tangent theta is 5.25. Again, this is not an angle that we recognize. We will be going to our calculator and using inverse tangent this time. So inverse tangent 5.25, whichever order you need to enter that in your calculator. And rounding off to 2 decimal places, I get 1.38. Now, I would encourage you as you watch this lesson that you may want to pause your tape, get out your calculator, make sure that you're getting these same answers that I'm getting. Now, let's notice here the tangent was a positive value. What other quadrant do we have a positive tangent value besides quadrant 1? That would be over here in quadrant 3, wouldn't it? So my quadrant 1 answer is 1.38. If I go to quadrant 3, that 1.38 will be a reference for me, so I need to add this 1.38 to pi. And again, if you've got all that still left in your calculator, you can just do plus your pi button there, and you should have something like 4.52 after adding pi. So my second solution here is 4.52. Again, we're only getting the 2 solutions because we're only doing the 1 rotation. Use a calculator to find solutions in the interval 0 to 2 pi. Round off to 2 decimal places. Now this time we have cotangent x equals negative 3.27. Our calculator does not have an inverse cotangent button, does it? So we're going to have to do something about this. Let's recall that the tangent of x is 1 over the cotangent of x. So if I invert this number, I will get the tangent of x. So we can do that with our calculator actually. If you will enter that negative 3.27 into your calculator, you should have a 1 over x key or an x to the negative 1 key. And if you'll use that key, you'll have here that the tangent of x is approximately, I'm going to just round this off, negative 0.3058 something. So I'm getting this number by flipping this over, finding its reciprocal. Now that I have the tangent is this number, I'm going to do the inverse tangent of that value. Now we're going to have to be careful here because notice we're entering a negative number and doing inverse tangent. Recall the inverse tangent function had a restricted area between negative pi over 2 and positive pi over 2. My calculator is saying x is approximately negative 0.29677. It's got some more digits there that I'll not write down. Notice this negative in front of what your calculator is showing you. This negative number is not between 0 and 2 pi. If you're between 0 and 2 pi, you have a positive value, don't you? This has to be only a reference for us to use. It cannot be the solution. So let's think about what quadrants we're in here. If the cotangent is negative, that's equivalent to the tangent being negative, isn't it? Well, we know all the functions are positive here, and we know the tangent is positive here. So we have to be either in quadrant 2 or quadrant 4. Well, let's notice this number is bringing you down here into quadrant 4 with a negative value. What we want is the positive angle rotating in this direction to get us back to this same place. So with this negative 2.9677 thing already in my calculator, what I can do is just add 2 times pi to that. And what that's going to do, you see, is it's actually, since that was negative in my calculator, by saying plus 2 pi, I'm finding the difference there. and I have that x is approximately 5.99 when I do that. Now this is my quadrant 4 solution. So how do I go about getting the quadrant 2 solution? Well, this negative 0.2966 thing here, I'm going to round off to negative 0.30 to 2 decimal places. And so I will use that as a reference over here in quadrant 2. I won't consider it to be negative, but I know that the absolute value of that value will be this reference angle. So I need from here to here, which means I need pi minus that 0.30. So we can just take our pi and subtract that 0.30, and we have about 2.84 for our other solution here. Now it really doesn't matter which one of these you get first, but you do need to find both the quadrant 2 and quadrant 4 solution to our value. So recall, first of all, we're going to have to change cotangent into tangent so that we can do inverse tangent. And then because we got a negative value here, we've got to use that as a reference to get us in our proper quadrant. Use a calculator to find solutions in the interval 0 to 2 pi. Round off to 2 decimal places. We are given secant alpha equals 3.562. Now, do we have an inverse secant? No. But we know what? The cosine of alpha is 1 over the secant of alpha, isn't it? And so using our 1 over x key or our reciprocal key, let's take that 3.562 and invert it, x to the negative 1 or 1 over x. The cosine value is approximately 0.2807. We will have some more decimal places here. Now I'm going to use my inverse cosine key. And so based on my inverse cosine, I'm getting 1.29 if I round off. Now let's talk about the values here. Notice the secant value is positive, which is equivalent to saying the cosine is positive. That will put us in quadrant 1 or 4. This is my quadrant 1 solution. So if I'm going to go around here to quadrant 4, I need to use this 1.29 as a reference. So I need 2 pi subtract this number. So if you still have this in your calculator, just use your plus minus key to change it to a negative, and then you can just add 2 times pi to that. And so my second solution, if I round off, I'm showing here about 4.996. So if I round that off, that's going to be about 5.00. Let me double check that and make sure that I did that correctly. Yeah, well, yes, that's correct. About 5.00 or 4.99, depending on if you rounded off earlier. So our two values are approximately 1.29 and 5.00 here. Okay, I've got one more of these rather simple ones. I wanted to do one of each of these where we don't have the exact key on our calculator. Use a calculator to find solutions in the interval 0 to 2 pi, round off to 2 decimal places. The cosecant of x equals negative 2.413. Now, you should already be thinking what we're going to do. The sine of x is 1 over the cosecant of x. So we're going again to use our 1 over x or our x to the negative 1 key to find the reciprocal of this number. So I have here the sine of x is approximately negative 0.4144, and again it has more decimal places. Now we're going to do that inverse sine, and I'm getting a negative value here on my calculator, negative 0.43 if I round off. Now again, can our solution be negative if we want this? No, it can't. Remember again, our inverse sine on our calculator, if we put in a negative number, it's going to give us a negative value in the fourth quadrant. Well, let's think about if the cosecant is negative, the sine is negative. That will put you in quadrants 3 or 4, won't it, if the sine value is negative. This negative 0.43 is the value of our reference angle then. So what we need to do is to take pi and add 0.43 to get our third quadrant answer. That's about 3.57. And then we need to take 2 times pi and subtract that 0.43 to get our other solution. That's about 5.85, it looks like. Again, you may vary just a little bit on this round off depending on if you keep all of this in your calculator or if you round it off and then do the calculations. But keep in mind, this calculator first thing that we got is only going to be a reference. Now I hope with these first few simple examples you're kind of finding out what do we do once we get to a point when our equation says sine x equals, cosine x equals, tangent x equals, or whatever. If it's a value that we recognize, we will give exact value solutions based on our special angles. If it's not, then we will go to our calculator and use our inverse trig function keys to find those values. Now what I'm going to have us do next is to look at what I would call steps or suggestions for solving the more complicated looking trig equations. Let's take a look at those suggestions. Hints for solving trig equations. If only one trig function is in the equation, solve for that function. Notice we're saying to solve for the trig function, not the variable itself. If we solve for the trig function, then we're going to get down to a point where we've got something like this. A trig function equals a number. Okay? Now, if there's more than one trig function, get the equation equal to 0 and try to factor so that each factor contains only one trig function. What we're using here is that zero product idea. If you have two factors and their product is equal to 0, then you can set each factor equal to 0. So if we can separate those trig functions by factoring, we're going to want to do that, but we have to get a 0 in order to use that. If you cannot factor, try to think of an identity that might be used to get all of the trig functions alike. Recall those basic identities like sine squared x plus cosine squared x equals 1. We can put an alternate form, sine squared x equals 1 minus cosine squared x. So we can always replace a sine squared x with 1 minus cosine squared x. There will be other identities that we may talk about as we solve these equations. The fourth suggestion, you may sometimes need to square both sides of an equation in order to apply an identity. If you do square both sides, be sure to check for extraneous solutions. Recall from algebra, anytime you square both sides of an equation, you sometimes introduce these extraneous solutions. You have to be very careful there. If the equation is quadratic in form, but you cannot factor, don't forget you have the quadratic formula that you can use. We'll see one of those later on in our tape. Be sure to note whether you are finding all solutions or if you have a restriction. Remember, all solutions, we're going to tack on those revolutions to our primary solutions. If we have a restriction like just 0 to 2 pi or 0 degrees to 360 degrees, then we'll only have a couple of solutions perhaps. Also note whether your solutions are to be given in degrees or radians, meaning real numbers. I hope that these hints will help you as you look at an equation to decide how to approach it. Now, a lot of what you're going to do here is going to require not only your knowledge of trigonometry, but also your knowledge of algebra. How do you solve quadratic equations? You get them equal to 0, factor if you can, if not, use quadratic formula. If it's a linear type equation, your variable is to the first power, then you get the variable on one side, all the constants on the other. Those same sorts of things will apply to these trig equations. In the beginning, we're going to be solving for the trig function, so we'll be treating the trig function like a variable would be treated in algebra. Once we get down to that trig function equals a number, then we will start finding the solutions of our variable. Let's take a look at some equations now. Solve for x in the interval 0 to 2 pi. Now notice here, we can include the answer of 0, but we do not include the answer of 2 pi. The open parenthesis here is indicating that would not be part of the solution. Notice in this equation I only have the one trig function cosine x, so I'm going to solve for that trig function by subtracting this 2 from both sides of my equation. So if I subtract 2 on both sides of my equation will read cosine x equals 3. Now, before you grab your calculator, let's talk about this one. What do you recall about the cosine values? Aren't the cosine values of any angle or number always between 1 and -1? They are, aren't they? Now, if you don't remember that, if you pick up your calculator and you try to do an inverse cosine of 3, your calculator hopefully is going to tell you that you have an error there, that you can't do that. You should recognize that this is impossible. Cosine values must be between 1 and -1. So if this is impossible, we have no solution, and we can just go on to the next equation. Well, that one was easy enough, wasn't it? They're not all quite that simple. Here again, we're to solve for x in the interval 0 to 2 pi, including 0 but not 2 pi. Again, inspect your equation. Notice that the only trig function I have is secant x. So in the beginning, I'm treating this secant x sort of like my variable would be treated in algebra. I have these terms that are alike, so I want to get them on the same side of the equation. So I'm going to subtract this secant x from both sides. Well, 2 secant x minus 1 secant x is secant x. And then I still have that plus 1 over here equals 3. Now we're going to subtract 1 from both sides. We have secant x then equals 2. Now, I'm not usually familiar with secant, and so we learned in those last examples, if I invert this, I get the cosine, don't I? So the cosine of x will be 1 over 2. Now, I recognize 1 over 2. Remember your 30, 60, 90 triangle? Which one of those has a cosine of 1/2? It's the 60 degree that has a cosine of 1/2, isn't it? But notice I want my answer in radians, not in degrees. 60 degrees is the same thing as pi over 3, isn't it? So I'm going to say x is pi over 3. Now, is that my only solution? No, it isn't. Remember, we're doing one rotation here. The cosine value here is positive. The cosine is positive in quadrants 1 and 4, right? So if I use pi over 3 as a reference over here in quadrant 4, remember 2 pi would be 6 pi over 3. So if I subtract pi over 3 from 6 pi over 3, I get 5 pi over 3 for that second solution. Solve for x in the interval 0 to 2 pi. Now let's take a close look at this equation. Notice it says tangent x minus 1 times cosine x minus 1 is equal to 0. I have two factors here whose product is 0. So just like in algebra, my next step would be that I would set each of these factors equal to 0. So I have tangent x minus 1 equals 0 and cosine x minus 1 equals 0. Now let's solve for the trig functions. Tangent x would equal 1 or cosine x would equal 1. Well, now we can get our values here. Remember, we're trying to get radian solutions. What angle has a tangent of 1? That's 45 degrees or pi over 4. Now, tangent's positive in quadrants what? 1 and 3. So if we use pi over 4 as a reference over here in quadrant 3, pi would be 4 pi over 4 plus 1 more would give us 5 pi over 4. So we have the two solutions there from tangent x equals 1. What about cosine x equals 1? Well, the cosine of 0 is 1, isn't it? And then we don't hit 1 again until when? Until we get to 2 pi. But notice 2 pi with that parenthesis there is not included. So I only have the three solutions here, pi over 4, 5 pi over 4, and 0. Now in this equation, it was already factored for me. Keep in mind that if we multiply this out, the equation could have been in that long form and we would have had to get the factors. Solve for x in the interval 0 to 2 pi. My equation is 2 cosine squared x minus square root 3 times cosine x equals 0. Now notice, I just have the one trig function cosine x, but it is squared in this first term and to the first power here. Notice I've got this equal to 0. So that suggests to me that I might try factoring here. We have a common factor of cosine x. Let's factor that out. If I factor out cosine x, in the first term it will leave 2 times cosine x. And then I'll have minus. If I factor cosine x out of that second term, I get square root 3. Now notice if you multiply this back out, it should give you what you had up here. So make sure we have these correct factors. Now I'm going to set each of these factors equal to 0. So cosine x equals 0, or 2 cosine x minus the square root of 3 equals 0. This first one is already solved for the trig function, so let's work on this second one. 2 times the cosine of x would equal positive square root 3 if I add that square root 3 to both sides. And then dividing by 2, I get cosine x equals the square root of 3 divided by 2. Now notice again, we're getting radian solutions between 0 and 2 pi. So let's look at our first factor here. The cosine is 0 when? You might think about your cosine graph. That's a good thing to remember. Your cosine graph looks like this. The cosine is 0 where? At pi over 2 and 3 pi over 2. So let's write those down. Pi over 2 and 3 pi over 2 are two solutions that we're getting from this answer. Now, what about this cosine x equals square root 3 over 2? Those numbers are coming from your 30-60 triangle, aren't they? I'm going to put that one up here one more time. That triangle is so important to remember. Which one of these has a cosine of square root 3 over 2? It's 30 degrees. 30 degrees is pi over 6. So one of my solutions is pi over 6. Cosine is positive. That's quadrant 1 and 4. If you go to quadrant 4 with a pi over 6 reference, 2 pi is 12 pi over 6. So if you subtract pi over 6 from that, you get 11 pi over 6. Now how quickly you get these solutions sort of depends on how much you remember about your special values and also about finding these references and angles using your quadrants here. Solve for x in the interval 0 degrees, left off the degree sign there, to 360 degrees. So notice here we're changing from radians to degrees. Notice again, however, we may include an answer of 0 degrees but not 360 degrees. Well, let's take a look at our equation. Notice I've got two different trig functions here. But if I subtract that cosine x from this right-hand side over here and bring it over here to the left, I'll get a 0 over here. And then look, I have a common factor of cosine x. So let's factor that out. If I factor out cosine x, it leaves sine squared x minus 1 equals 0. So I can solve the first factor, cosine x equals 0. The second factor, sine squared x minus 1 equals 0. This is already solved for the trig function. In my second factor, first of all, I'm going to solve for sine squared. Sine squared x would equal 1. Now, to take the square root, I need to remember what? There's two square roots. So if I'm going to take the square root here to get sine x, I need to remember that that could be positive 1 or negative 1. Now, let's get our solutions then for x. Remember, we're doing degrees now. The cosine is 0 at pi over 2 or 90 degrees, at 3 pi over 2 or 270 degrees. Notice that the sine is 1 at 90 degrees and it's negative 1 at 270 degrees. So we're not going to get any new solutions from this answer right here, are we? It's the same two values. So we'll just write those down one time and we will have all of our solutions. Solve for x in the interval 0 degrees to 360 degrees. Use a calculator and express solutions to the nearest tenth of a degree. I guess that's a hint that maybe these aren't going to be special angles for us. Notice I do have one trig function. So I'm going to subtract to get all of these on the same side and get a 0. Now I can factor out secant x. That leaves 5 secant x minus 6. So I have here that the secant of x is equal to 0, or 5 secant x minus 6 equals 0. Now this is already solved for my trig function. Here I'm going to solve for secant. 5 secant x equals 6. So the secant of x will be 6/5. Now let's talk about this first one right here. Secant x equals 0. Can that happen? There's two things here that should tell you that that cannot happen. One would be to recall your graph of your secant function. Remember what that thing looked like? If you recall, your secant graph did something like this. Remember that thing? It was always, what, above 1 or below -1. It was never equal 0. If you don't remember that, think about if you try to flip this over to get cosine. Can you flip over a 0 over 1 and get 1 over 0? That would be undefined. We're getting no solutions from this factor. But notice over here I can invert this and say that the cosine is 5 over 6. That one is going to give me some solutions. Now because I'm wanting degree solutions here, the last time we were working with our calculator we were doing radians, so the first thing you should do is make sure that you change that and change your mode over to degree mode. We are going to do inverse cosine of this 5/6. Now you may need to use a parenthesis key in your calculator to enter that correctly. So if we do the inverse cosine of 5/6, I'm reading off of my calculator 33.6 degrees. Notice it said to the nearest tenth of a degree, so x is approximately 33.6 degrees according to my calculator. Now, this is not my only solution because the cosine is positive again in quadrants 1 and 4. So this is my quadrant 1 solution. To get my quadrant 4 solution, I need to use this as a reference down here in quadrant 4. So if I use 33.6 degrees here, what I need to do is take 360 degrees and subtract that 33.6. That gives me 326.4 for my second solution. Find all real solutions. All solutions. So that's indicating again that thing when we were doing revolutions. What does it mean by real solutions? That's not that's not degrees, that's radians. Radians are real numbers. And so we want radian solutions and we want all of them. Now let's look at this. There's only one trig function here. This one is to the second power, this one is to the first power. So this is sort of like in algebra when you have a quadratic equation. So when we have a quadratic equation in algebra, we get everything on one side and get it equal to 0, don't we? So we're going to do that here. 2 sine squared theta minus 3 sine theta plus 1 equals 0. Now I think we might be able to factor this one. Let's see. If I do 2 sine theta times sine theta, if I use minus 1 and minus 1 here, let's check this out. I've got 2 sine squared theta minus 2 sine theta minus 1 sine theta is minus 3 sine theta for that middle term plus 1. So I do have the correct factors. Since I was able to factor Now I can set each of these factors equal to 0. So 2 sine theta minus 1 is equal to 0, or sine theta minus 1 is equal to 0. We'll solve this first one for the sine of theta. So 2 sine theta equals 1, adding 1 to both sides, and then dividing by 2, sine theta is 1/2. In my second factor, I just need to add 1 to both sides to have it solved for sine theta. Now, these are numbers that I recognize. I'm wanting radians. So what I'm going to do first is to get what I'm going to call my primary solutions. Let's start here. We know that 30 degrees, or pi over 6, has a sine value of 1/2, don't we? So we're going to have that solution. Now, we also know that the sine is positive in quadrant 2. So if we use pi over 6 as a reference in quadrant 2, we're going to get 5 pi over 6. Okay? Now, the sine is 1 at where? Pi over 2. And that's the only place, as far as 1 revolution is concerned, where we have a sine value of 1. I have 3 what I'm calling primary solutions here. Now, to take care of all solutions, all I'm going to do is to add 2 pi k to each of these primary solutions. So what that's saying is these 3 are answers. If I do a revolution to each one, or 2 revolutions, or 3 revolutions, etc., then I will generate all possible solutions to this equation. Solve for x in the interval 0 to 360 degrees. Use a calculator and express solutions to the nearest tenth of a degree. Well, we'll see the reason for the calculator here in just a second. Notice this is also a quadratic type equation, isn't it? It's already in standard form. But you might play with it a second and realize that it won't factor. Okay? So, just like in algebra, if you have an equation that won't factor, you use the quadratic formula. Now, let me just sort of talk about that, and I'm going to use a different variable so we don't confuse it with this x. If I have 2y squared plus 2y minus 1 equals 0, if I'm going to use the quadratic formula, I'm finding what? Y equals minus b plus or minus square root b squared minus 4ac all over 2a. Remember that? Well, here, because I'm treating my trig function like my variable here, when I use that quadratic formula, I will be finding the sine of x. So the sine of x will equal minus b. Well, my b is a positive 2, so minus b would be a negative 2. Plus or minus square root, b squared then is 4, minus 4 times the product of a and c. Well, a times c is a negative 2. And then all of this is divided by 2 times a. 2 times 2 is 4. Now, let's simplify this. We have negative 2 plus or minus. Notice this is going to be a positive 8 plus 4 is 12 under that square root. And we know that 12 being 4 times 3, we can simplify as 2 times the square root of 3. Notice here then I can factor a 2 out of the numerator, and by doing that the 2 will cancel with this denominator, and so finally what I have is negative 1 plus or minus the square root of 3 divided by 2. Now remember, this is the sine of x. So what I'm going to do here is to take my calculator and evaluate both of these. Now let's do negative 1 plus the square root of 3 divided by 2. Now you're going to need to be careful with this. Do your negative 1 plus your square root of 3, and then you need to complete that. Hit an equal or enter to complete that calculation before you hit that divide key to divide by 2. I have here approximately, I'll put it up here, 0.366, 0, 2, 5, etc. Now, while that's in my calculator, I'm going to go ahead and do an inverse sine for that. And I was set for degrees, so I'm getting x is approximately 21.5 degrees here, 21.5. Now, my sine value was positive. This is my first quadrant answer. So for my second quadrant answer, I need 180 degrees minus that 21.5. That gives me 158.5 degrees. So there's my two answers using -1 plus the square root of 3 all divided by 2. Now we're going to go back here and we're going to do that -1 minus the square root of 3. Again, remember to complete that before you hit that divide. And on this second one, I'm getting that the sine of x is approximately -1.366, etc., etc. But I want you to look at this. -1.366. We know again that the sine of x must be between what? -1 and +1. This is outside that value. So we will get no solutions from this second value here. Nothing, that is impossible for us to get values for the sine of x being -1.366. If you did not catch that, if you do inverse sine on your calculator with that negative number in there, that -1.366, it will give you an error statement. Solve for x in the interval 0 degrees to 360 degrees. Use a calculator and express solutions to the nearest tenth of a degree. This is going to be very similar to the example we just did. Notice I have the one trig function. It's squared here, first power here. This is not in standard form. It's not equal 0. So my first step will be to bring that over and get it equal to 0. Now again, can we factor this one? Well, let's see. You know, if that was a +1, we'd be able to, but because of that being a -1, we're not going to be able to. So again, we're going to go to the quadratic formula here, and this time we will be finding the cosine of x. So my b is a +4, so minus b would be -4, plus or minus square root, b squared is 16, minus 4 times the product of a and c. 4 times -1 is -4. All divided by 2 times 4 are 8. -4 plus or minus, well, let's see what happens here. That's a +16 plus 16 is 32. And let's see, since that's 16 times 2, I can simplify that as 4 square root 2. And then I can factor a 4 out of the numerator and cancel. So I have here -1 plus or minus the square root of 2 all divided by 2. Let me come up here and we're going to go to our calculator. So again, let's take the -1 plus the square root of 2, complete that, divide by 2. I have about 0.207, etc., etc. I'm just going to leave that in my calculator and do inverse cosine. And I'm reading here then that x would be approximately 78. Let's say nearest tenth of a degree, that's not quite, I've got 0.04, so I'm just going to say 78.0 degrees. Okay, now while we're here, the cosine value was positive. That's my quadrant 1 answer. The cosine is also positive in quadrant what? 4. So I need 360 minus that 78 gives me 282.0 degrees as my second value. Okay, now let's go to the other value here for cosine. Using the -1 minus the square root of 2, complete that, divide by 2, and here I'm getting -1.207. What's going to be true here? That's outside our range, isn't it, for cosine x? So there's no solutions from that factor there. Solve for x in the interval 0 degrees to 360 degrees. Our equation this time says cosine squared x equals sine squared x plus 1. Well, I have two different trig functions this time, don't I? And even if I subtract one of these or the other to get it to the other side of the equation, I will not be able to factor. So what I'm going to do here is to use an identity. Remember I said earlier that we can change sine squared to 1 minus cosine squared, or if we prefer, we can change cosine squared to 1 minus sine squared. It actually makes no difference here which way you want to go. I think what I'm going to do here is change cosine squared to 1 minus sine squared. Now, notice that if I add this sine squared, I'm going to get 1 equals 2 sine squared x plus 1. If I subtract 1, I get 0 is 2 times sine squared x. Dividing by 2, I still have 0 here is sine squared x. Well, the square root of 0 is just 0. So this is just saying the sine of x is 0. Well, we want degree answers. So for what degrees is the sine of x equal to 0? Well, it's 0 at 0 degrees, and it's 0 again at 180 degrees, isn't it? So those would be our only two solutions here between 0 and 360 degrees. Now, if you had chosen to replace this with 1 minus cosine squared x, you should end up with these very same solutions. Your equation would look a little different, but you will get the very same answers at the end. So we're looking for an identity so we can get one trig function here. Solve for x in the interval 0 degrees to 360 degrees. Here it says we're going to need to use a calculator and express solutions to the nearest tenth of a degree. Now notice here I've got two different trig functions, cosine and cotangent. And just offhand, I don't think of a lot of identities involving those, but I do know that cotangent is what? Cosine over sine. Let's take a look at that. 8 cosine x. In place of cotangent, I'm going to put cosine over sine. Now, I don't really want to work with this fraction thing, so what I'm going to do here is to rewrite this as cosine x times cosecant x. Now, where did that cosecant x come from? 1 over sine is cosecant. So I left the cosine here. What I'm actually saying is this is equivalent to cosine x times 1 over sine x. And then I can do this. Now, let's subtract this to get everything over here and equal to 0. Now I have this common factor of cosine x, so I'm going to factor that out, 8 minus cosecant x. So I have cosine x equals 0, or 8 minus cosecant x equals 0. Of course, here we're going to get 8 is cosecant x. Okay? Now, we can work with this one. The cosine of x is 0. Now I'm wanting degree answers. The cosine is 0 where? At 90 degrees and 270 degrees, isn't it? Now, I don't like to work with the cosecant, so let's flip that thing over. The cosecant, if I do the reciprocal, what do I get? I get sine. So the sine of x is 1/8, isn't it? Okay? Well, here's where we're going to need to go to our calculator, because we need to do the inverse sine of this 1/8. Now again, you may need to use a parenthesis to get that 1/8 thing in there. According to my calculator, if I round off to the nearest tenth of a degree, I have 7.2 degrees for x. Now my sine value is positive in quadrants, what, 1 and 2. So I need 180 degrees minus this 7.2. That's 172.8 degrees. So you'll notice on this one that 2 of the solutions I did not need my calculator for, but 2 of them I did. Now, I've sort of not mentioned this earlier, but I do want to point this out here. A lot of students, when they get to this point, want to divide both sides of this equation by cosine x. And if you do that, you would get 8 equals 1 over sine x, or sine x equals 1/8. You would get this, but you would lose this factor here, and that's part of our solutions. So always, if you can at all, avoid dividing by a trig function, because you may lose solutions when you do that. It's much better to get everything on one side and factor. That way you're not losing part of those solutions. Here we are to determine all solutions. So we're going to have to think about revolutions here. We want to use radian measure. Now let's take a look at our equation. 2 cotangent squared alpha plus cosecant squared alpha minus 2 equals 0. I have two different trig functions. Notice these are both squared. Are you thinking about the identity that I'm thinking about? 1 plus cotangent squared alpha equals cosecant squared alpha. Remember that identity? 1 plus cotangent squared equals cosecant squared. So what I'm going to do here is bring down this 2 cotangent squared alpha. In place of this cosecant squared alpha, I'm going to put 1 plus cotangent squared alpha. Bring down the minus 2 equals 0. Now notice we can add these. I have 3 cotangent squared alpha. 1 minus 2 is a negative 1 equals 0. So 3 cotangent squared alpha equals 1. Cotangent squared alpha is 1/3. I'm going to go ahead and flip this over and make it into a tangent. So tangent squared alpha is 3. Now, if I take a square root, remember I have to do what? Plus or minus square root 3. Now, let's think about that square root 3. We know that's coming off of our 30-60 triangle, right? 1, 2, square root 3. Tangent of 60 is square root 3 over 1. 60 degrees is equal pi over 3. So I want to have alpha being pi over 3. Now, notice here, my tangent value is either positive or negative. That means I can be in any quadrant, right? So if I use pi over 3 in the second quadrant as a reference, I'll get 2 pi over 3. If I use pi over 3 as a reference in the third quadrant, I get 4 pi over 3. And if I use pi over 3 as a reference in the fourth quadrant, I get 5 pi over 3. Now these are my primary solutions, one for each quadrant. Now since it said all solutions, I'm going to add my revolutions plus 2 pi k. Determine all solutions, again, all solutions, using radian measure. Okay, well let's take a look at this. Cosine beta plus 2 secant beta equals negative 3. Different trig functions, aren't they? Can you think of an identity that we might use here? Secant equals what? 1 over cosine, doesn't it? Let's use that. Cosine beta plus 2 times 1 over cosine beta equals negative 3. Now, what I'm going to do here is clear the fraction. So I'm going to multiply both sides of this equation by cosine beta. So cosine beta times cosine beta is cosine squared beta. Notice in the second term I'm going to get a 2 because 1 over cosine is going to cancel the cosine here. Equals negative 3 cosine beta. Now let's pull this over here and put this in standard form for a quadratic. Cosine squared beta plus 3 cosine beta plus 2 equals 0. Now I think we're going to be able to factor this one. Cosine beta plus 2 times cosine beta plus 1. Isn't that correct? 2 and 1 is 3. Okay. Then we will set each factor equal to 0. And then we'll solve for the cosine. Here we have cosine beta equals -2. Are you thinking ahead? Can that happen? Can't happen, can it? No solutions there. Here we get cosine beta equals -1. We can get solutions here. So let's see, where is the cosine equal to -1? That's at pi, isn't it? All solutions, we're just going to add 2 pi k to that. Pi plus 2 pi k. Now, you might see this answer written slightly different. Notice pi plus 2 pi k, if I factor out the pi, I have pi times 1 plus 2k. A lot of times you will see this written as 2k plus 1 times pi. It's the same difference. This is okay. You don't have to do that factoring, but I thought I'd warn you because a lot of times you'll see the answer written like this. Solve for x in the interval 0 degrees to 360 degrees. Our equation is 4 times 1 plus sine theta equals 3 over 1 minus sine theta. Now, if this were an algebra problem and I had a 1 plus x here and a 1 minus x here, I probably would clear the fractions. So that's what I'm going to suggest that we do. Let's multiply both sides by 1 minus sine x. Now, what I'm going to do on this other side, on this left-hand side, let's bring that 4 down. What happens when you multiply 1 minus sine x times 1 plus sine x? You get difference of squares, don't you? 1 minus sine squared x here. And of course, on this right-hand side, those are going to cancel out and leave 3. Okay, if we distribute this 4 minus 4 sine squared x equals 3. I'm going to subtract the 4, so -4 sine squared x equals -1. Then dividing by -4, I get sine squared x equals positive 1/4. I'm ready to take a square root now. Sine x will be plus or minus 1/2. The square root of 1/4 is 1/2. But notice that plus or minus thing on there. Since I have plus or minus, the sign can be positive or negative, then we're in all 4 quadrants, right? Well, the sine of what? 30 degrees is 1/2. So we know x is 30 degrees in the first quadrant. Using 30 as a reference in the second quadrant, we get 150. Using 30 as a reference in the third quadrant, we get 210. And 30 as a reference in the fourth quadrant, we get 330 degrees. So those would be our 4 solutions for this equation. Are you noticing here that we're doing a lot of things just like we would do them in algebra? Clear that fraction out, and then as it turns out, the equation from there works out rather nicely. Determine all solutions of the given equation using radian measure. Secant x plus tangent x equals the square root of 3. Now, this one has 2 different trig functions. There is an identity for secant and tangent, but if you remember, it's in squared form. Tangent squared x plus 1 would equal secant squared x. Because it's in that squared form, that suggests to me that I might want to square to get secant squared and tangent squared, but I do want to caution you here. Before you square, I want you to separate your trig functions. Get one on one side by itself and one on the other. I think what I'm going to do here is, let's leave this secant over here, and we're going to subtract the tangent of x from this square root 3. So I'm going to write this as secant x equals square root 3 minus tangent x. Now, we're going to square both sides. You have to be really careful here, just like you had to be in algebra. On the left, we get secant squared x, but notice on the right, we're squaring a binomial. So we square the first term and get 3. We multiply the first term times the second term and double that answer. So we'll have minus 2 square root 3 tangent x. And then finally we square this last term and get a positive tangent squared x. Now, see, by squaring both sides, that has allowed me to get secant squared here, which I can replace with tangent squared x plus 1. So let's do that. Tangent squared x plus 1 equals 3 minus 2 square root 3 tangent x plus tangent squared x. Now notice here, if I subtract tangent squared x from both sides, those just drop out, don't they? Okay, so I'm going to subtract this 3 then, and I get a negative 2 equals negative 2 square root 3 times tangent x. And then dividing by negative 2 square root 3 to get tangent x. This will simplify to a positive 1 over the square root of 3 for tangent x. Okay? Now, I'm thinking about that 30-60 triangle again. 1, 2 square root 3. If the tangent is 1 over the square root of 3, that's 30 degrees or pi over 6. Okay, my tangent value is positive. That's quadrant 1. The tangent is also positive in quadrant what? 3. So if we use pi over 6 here, we'll get 7 pi over 6, won't we? Now, this said to determine all solutions. We have found 2 primary solutions, and so it's real tempting here just to put plus 2 pi k plus 2 pi k and go on about our business. But I want to remind you that when we looked at the hints, you may sometimes need to square both sides, which we did. If you do square both sides, be what? Be sure to check for extraneous solutions. Before I decide that these are, in fact, my primary solutions, I need to check my answers here. Now, if the primary solutions check, then after you do revolutions, they will also check because you would be in the same quadrant. We're going to check in our original equation. So let's check this pi over 6. The secant of pi over 6 plus the tangent of pi over 6, we want to know, does that equal square root 3? Okay? Well, again, if it helps you to think degrees, if you're not real confident in radians, then you can think that, but I hope that you're confident in radians. If you need to think about this instead of thinking secant, secant is 1 over cosine. Okay? So, if you're needing to refer to your triangle here, pi over 6 is like 30 degrees. The cosine is square root 3 over 2. So I have 1 over square root 3 over 2 plus the tangent of my pi over 6 is 1 over square root 3. Of course, on this complex fraction here, we'll invert and multiply. We'll get 2 over the square root of 3 plus 1 over the square root of 3 equals 3 over the square root of 3. Let's rationalize this. So I have 3 square root 3 over 3. The 3's cancel. And guess what? I do get square root 3. So my pi over 6 checks. That means I can go ahead and say plus 2 pi k here. Okay? Now, 7 pi over 6 will have the same numerical values, but 7 pi over 6 is in quadrant what? 3. So what's going to be different when we put a 7 pi over 6 here? Well, the cosine in quadrant 3 is what? It's negative. So this would be a negative here. The tangent is still positive. So I would get negative 2 over the square root of 3 plus 1 over the square root of 3 is a negative 1 over the square root of 3. That is not going to equal positive square root 3. This second answer here is extraneous. It does not check. So I only want that solution there. Usually if you check one of your answers, your easiest one, the other one will be very similar in terms of the check, but sometimes there'll be a sign change because of the quadrant change. I've got one more equation that I want us to do And it's similar to this one that we just did. We're solving for x in the interval 0 to 360 degrees here. And we want to use a calculator on this one, it says, so we're not going to get necessarily an angle that we recognize. But let's look at this thing. I've got sine and cosine. That's two different trig functions. And again, I'm thinking I know this. Sine squared x plus cosine squared x equals 1. So I can change a sine squared or a cosine squared into the other function. So I'm going to square both sides here. 2 sine x. I'm going to rewrite this to show that I'm going to square so I won't have that messed up when I'm ready to check after a while. So here I'll get 4 sine squared x. Again, notice you're squaring a binomial here. 1 minus 4 cosine x plus 4 cosine squared x. Now I'm going to replace this sine squared right here with 1 minus cosine squared x. I'm just recopying this right hand side over here. Let's distribute this 4. 4 minus 4 cosine squared x equals 1 minus 4 cosine x plus 4 cosine squared x. Now, notice since this is negative, I'm going to add and bring it over here. So we're going to get our 0 over here. Let's put this in order. If I add 4 cosine squared to 4 cosine squared, I get 8 cosine squared x. And then I've got this minus 4 cosine x here. And if I subtract 4 from 1, I get a negative 3. Okay? Well, let's think about this one. I have a feeling that maybe since he said we use a calculator that this might not factor. Then again, it's possible that it would. So what do you think? Do you want to try factoring? I think I'm just going to go ahead and go straight to the quadratic formula rather than wasting time trying to factor this thing. So let's start. We'll have a cosine x equals minus b would be a positive 4 plus or minus square root. B squared would be 16 minus 4 times the product of a and c. Well, a times c is a negative 24 and 2 times a is 16. Okay, let me come on over here and we're going to do a little simplifying. I'm going to suggest we grab a calculator here. Notice this is going to be a positive. So if you take 4 times 24 and add 16, I'm getting 112 here. Well, let's see, 112, actually I think 112 is divisible by 16. Yes, it is. It's 16 times 7. So 4 plus or minus 4 square root 7 over 16. I can factor a 4 out of the numerator, 1 plus or minus square root 7 over 16, and then that will allow me to cancel here. Now I'm running out of space, so let me get another sheet of paper and bring that up. We have the cosine of x is 1 plus or minus the square root of 7 all divided by 4. That's where we are. Now let's go to our calculator and let's do the 1 plus square root 7, complete that, divide by 4. My first value of cosine here is approximately 0.9114, etc. Now, keep in mind, we should be set for degrees. We want degree answers here. So, with your calculator set for degrees, we're going to do inverse cosine. And I have 24.3 degrees here, 24.3 degrees. That's my quadrant 1 solution. The cosine is positive, so that's also true in quadrant 4. So 360 minus the 24.3 reference would be 335.7. So there's my two answers using 1 plus the square root of 7 divided by 4. Now, let's look at the other cosine value here. Let's take 1 minus the square root of 7, complete that, divide by 4. I have a negative 0.4114, etc. Notice that is within our range, so let's do inverse cosine there. and that is giving me 114.3 degrees. Now notice this cosine value is negative. This is my quadrant 2 answer. Okay? So we need to also get the quadrant 3 answer. Let's talk about that. Let me slide this up here so you can see it. We have 114.3 degrees. That gets us in quadrant 2 where the cosine is negative. I also need to go to quadrant 3 where the cosine is negative. I need this reference. So that's going to be what? 180 minus the 114.3. My reference is 65.7. So I'll use 65.7 here. That means I need to add 180 degrees to 65.7. And that gives me 245.7 degrees. So we have 4 solutions here, 2 coming from the positive cosine value and 2 from the negative. Again, what prompted me to square both sides was the fact that I have this identity. Okay? We got down to a point that we had sine squared that we could change to 1 minus cosine squared, went to the quadratic formula, and now we've got these 4 answers. But wait a minute, before we quit, are we sure these are all correct? We're not, are we? Remember, we squared both sides of this equation. So we need to check in our original equation. 2 sine x equals 1 minus 2 cosine x. Now we have rounded these values off. So we may not be exactly perfect here, but let's try something. Let's use this 24.3 degrees. 2 times the sine of 24.3 degrees gives me approximately 0.823, I'm going to say. Now, on the other side, I have 1 minus 2 times the cosine. I'm going to try that 24.3 degree thing there. Well, you know what? I'm getting a negative 0.823. So could those be equal? No. So we're going to X that one. That one doesn't work. Well, let's try the 335.7. 2 times the sine, 335.7 equals. Here I'm getting negative 0.823. Alright, well let's go the other side. 1 minus 2 times the cosine of 335.7. And over here I've got negative 0.823. So that one is checking out. That one's okay. Alright, now let's try the 114.3. 2 times the sine of 114.3. I'm getting 1.823 approximately. Okay, on the other side, 1 minus 2 times the cosine of 114.3 degrees. And here I've got 1.823, so that one's checking. Okay, we've got one more to do. 2 times the sine of 245.7 is approximately negative 1.823. And let's see, 1 minus 2 times the cosine of 245.7 degrees. I'm getting positive 1.823. Can those be equal? No. So we'll X that one out also. So it turned out of these 4 solutions, 2 of them were extraneous. So you must remember, if you square both sides of an equation, you always need to check those answers to be sure that they are indeed correct. This concludes our lesson on solving trig equations. I know that it's been a rather long lesson, but I wanted to try to give you a lot of different examples because you run into so many different kinds of situations. There will be another lesson also on solving trig equations where you have multiple angles. I encourage you to really make sure you understand this lesson on solving these sort of basic trig equations first before you attempt to go on to those multiple angle solutions. I hope that this really does help you in working with your trig stuff. It's so very important, again, to remember that you've got to go back to the beginning of trig and know how to use those reference angles, which quadrants your trig functions are positive or negative in, working with radians or degrees, knowing those values of your 30, 60, pi over 6, pi over 3 things. All of that's so important to be able to be successful solving these equations. And of course also just your algebra background, because so much of what we're doing relies on the same types of techniques that we used in algebra.